One thing that the question writers for the AP exam are consistent with is they are always looking for ways to throw a monkey wrench into problems. And a few times over the past 10 years, they've presented differential equations to students not in terms of x and y, but in terms of time. So like in this case, we see q and t, or w and t, or b and t. And if you go back and you look at some old AP questions, you'll see that happening. And when that happens, oftentimes students just get flustered because they're used to dealing with y's and x's and not so much with t, and they just throws them all off and they just often say, forget it, I'm done, I'm not going to try it. But that shouldn't be a deterrent for you, all right? Because if you're used to x's and y's, there's nothing wrong with taking those variables and just changing them. You have to solve the problem, solve it in a way that works for you. We know that it's always dy over dx. So if we look at a situation like this where we see dq over t, what you may want to do, and what I'm going to do for this example, is let's change all the variables. The q's are in the y spot. So I'm going to have a y here, which means I need a y there. And the t is in the x spot. Well, there's only one t visible, so that's going to become x. So what are we looking at here? We've got dy dx is equal to 1/8 times 40 minus y. Okay, now it's a lot easier, I think at least, to solve this differential equation. I'm not worried about these q's or anything like that. X's and y's, what I know. All right, so what do we have to move? Well, the 1/8, that's going to stay, because remember we want to move as little as possible. But the 40's got to go with the y. So we got to divide both sides by 40 minus y. The dx is going to move over as usual. So what we end up having here is dy over 40 minus y is equal to 1/8 dx. And now we've separated the variables and we've earned that first point, which leads us to the second point, which is that we need to antiderive both sides. Now again, the antiderivative on the right is nice and easy. It's a constant. So all we're going to do with our antiderivative is just chuck an x after it. So we have 1/8 x. That's an 8, sorry. There we go. I'll hold off on the plus c. We'll go through in the appropriate order. There we go. So 1/8 x. Okay. What's happening on the other side? Well, this is similar to example number 13, where we had y plus 5 in the denominator, but now we see it's 40 minus y. And if you recall, we did some u substitution. All right, so if we make u equal to that denominator, 40 minus y, what is the derivative of 40 minus y? Well, the 40 derives to 0, but we have a negative sign in front of our y. So our answer is not going to be dy, it's going to be the opposite of dy, because that negative sign is going to move down into the derivative. So we have the opposite of dy. Now let's go back here. We've got dy in the numerator, but we want the opposite of dy. So we have to counterbalance that with an opposite sign right there as well. Okay, so now we can take our antiderivative, and it is going to involve natural log again, but we need that negative symbol in front of the natural log. So we have negative natural log, absolute value, 40 minus y equals 1/8 x. That's our antiderivative of both sides. We still need our plus c. So there's our third step, putting that in. Okay, now let's figure out what c is. Well, the initial condition, which I did not write on the board, says that when you plug in 0 for x, y is 5. Right? So we're going to plug 0 in for x, so that means we have 0 plus c, and that's equal to the negative natural log of 35. 40 minus 5 is 35. So c is the opposite of the natural log of 35. Okay, so what does that mean? We put this back in here. We have the opposite of the natural log of the absolute value of 40 minus y is equal to 1/8 x minus the natural log of 35. Right? We got to get rid of the negative sign. That's easy. Just we'll negate everything. So that becomes positive. This becomes negative. That becomes positive. Now we have to get rid of the natural log. How do we do that? Exactly. We're going to use e. So we're going to raise both sides up into the exponent of e. Right? And in doing so, we now have 40 minus y. And again, it's positive because the other side is e. Right? And we have e to the negative 1/8 x plus the natural log of 35. We know that we have to get rid of this 40. So we're going to end up subtracting 40 from both sides, all right, like so. And then we also need to get rid of that negative sign. So we're going to negate the y, which makes it positive, but we also have to negate the e, and we also have to negate the negative 40. All right, so we have this answer right over here on the right. Again, we just want to be ready for, we see here we have the natural log of 35, so this could be written as negative 35 e to the 1/8 x plus 40. Or if you want to be really neat with everything, we can put the 40 first, so we have 40 minus 35 e to the 1/8 x. That's what y is equal to. That's a good answer. Or we can also go back to our original letters and say that q, or q of t, your call, I'll write q of t, I'm barely squeaking that in there, is equal to 40 minus 35 e to the 1/8 t, or we can even do t over 8. It's one and the same. So it's a heck of a problem, but one that we want to be prepared for in case it comes up on the exam.